I've had a few students contact me on how to do the degrees of freedom and as well as the sum of squares between, within, and total. So I thought I would do just a real quick example for you. I've used chapter 12, exercise number 6 online. If you're looking at the end of the chapter, it's question 22. So I've got this example here for you. And what I'm going to do is just zoom out a little bit and see if I can show my work over here. So the first thing that I would do is write down the formula for sum of squares between. Okay, and you'll see here I have that listed. All right, so we need our T value, which is our total for the category, and then we need our G value. So we know our T's. I'm going to go slowly over here. That's been provided for you. So we're just going to square each one of those and then add them because we want the sum of T's squared. So when we go over and we do that, let's see if I can scooch these together and pan out a little bit. We've got our 90 squared plus 54 squared plus 36 squared, okay, divided by the small n, which is the number of values or the number of subjects in that each category, and that's 6, okay. Then the problem has provided the G for you, which is 180. We're going to square that and divide it by the capital N, which is the total number of values or subjects or whatever it is you're examining. So when we plug in those numbers, okay, when we have our sum of T over N minus our G squared over large N, we get 252. So I'm going to come over here and put that value in. So we have our sum of squares between. The next one that I would do is sum of squares within. I think the math is a little easier, the formula is a little easier, so I always go with my totals next. So I've got that formula written down over here for you. Your sum of x squared minus g squared over large N. The problem has provided your sum of x squared here, 2,150, so it's just putting that number in. And then it's also provided your g. For the formula, we need g squared. So I've come back over here and I've put in the 2,150 minus 180 squared, okay? And then divide it by the large N, which is 18 for this particular problem. We plug all of that in and we end up with a sum of squares total of 350. So I'm going to put that in here. And then the easiest thing to do is just simple math. 350 minus 252, and we get the sum of squares within of 98. All right, next we move on to degrees of freedom. I find that it's the same as sum of squares, that I start with sum of squares between. For degrees of freedom, that is k minus 1, or the number of categories you have minus 1. So the categories we have are non-migrating, short distance and long distance. So that's 3 minus 1. So degrees of freedom between is 2. And then next I would do your total, which is large N minus 1. And we know our large N is 18 minus 1 is 17. So then again, it's just simple math, and you get that within of 15. Next, we're going to find our mean sum of squares, and that is your sum of squares between divided by your degrees of freedom between, and then you take your sum of squares within divided by your degrees of freedom within. So when we do that, 252 divided by 2, we get 126, and then we have 98 divided by 15, we get 653. And then we get our obtained F value by dividing those two numbers, and that gives us 19.29. Now, if you look in the back of the book with your values, you'll find that our critical T is 3.68. And I've had some students say that they struggle with when to reject the null and when to fail to reject the null. So the easiest thing for me to do is visualize it. So let's draw our nice little bell-shaped curve that you've seen many times throughout. And what I will do is I will mark my critical, okay? So let's say my critical is 3.68, which we know it is by looking it up in the back of the book. And then I'm going to shade this area in here. I apologize, I'm trying to hold the phone and color at the same time. All right, so if my obtained value falls in this white area, then it's not significant enough that I can say whatever I've done or whatever I'm researching makes a difference. If it falls, a significant difference. If it falls in the shaded area, then I can be fairly confident, I believe we're at the 0.05 level, that whatever I'm researching or whatever I'm looking at, whatever I've done, is outside of the probability that would happen naturally, per se. So my obtained critical is 19.29, which is going to be way out here in this dark area. So because that's the case, I reject the null. There are significant differences among the three groups. If I would have failed to reject, it would have been out here in this white area. So I'm saying there is significant enough difference. So again, that's when you reject the null, is when it falls in this dark area. 19.29, I'm going to write that down, bear with me real quick. 19.29, I'm going to put that way out here so we know it definitely falls in the dark shaded area. And that's how you know if you reject the null or you fail to reject. Again, if it falls in the white area, you fail to reject. Null hypothesis always means there is no difference. So we're saying because it falls in the shaded area, there is a difference. So we're going to reject the null that there's no difference. So I hope this helps. As always, if you have any questions, feel free to contact me.